Now we're going to move down into the tropics. This is not about extratropical cyclones now. We're talking about tropical cyclones. So there's a difference. So what is that difference? Most of these form between 23.5 degrees north and 23.5 degrees south. Why is that? Well, first off, no fronts get down there. So the air mass is pretty uniformly kind of warm over the oceans, fairly humid. So there's a large area here with no changes in weather very much at all. No front going to bring temperatures down into the 30s or whatever. This is an area without that. So temperature contrast, we take it right out of everything right now. So in the tropics, you can get intense thunderstorms that kind of line up in squall clusters, and they do move around the globe. Hurricanes, on the other hand, are very intense cyclones. And what I mean intense, think about, we talk about pressure gradients. We've talked about pressure gradients relating to wind. Well, on a nor'easter, a powerful nor'easter, we can get 75 mile per hour winds sometimes. And the pressure gradient might go from a high with 1040 millibars to a low, maybe down around 950 or 960 millibars. But that's over probably almost 1,000 miles. In a hurricane, we may have 1,200 millibars, and within a couple hundred miles, be down around 920 millibars. So look at the change in pressure there over such a short distance. Hurricanes have much, much greater pressure gradients than others. Hurricanes also originate in this warm, humid air. So we start out with a warm core circulation. We just talked about the difference between cold core and warm core. Well, hurricanes are warm core. They can become cold core. Not ruling that out. But when they form, in most of their life cycle, they are a warm core system, which means that they actually have an extratropic, an anticyclone over top of them. And they have an eye, and they even have a beautiful eye wall if you're inside the eye. And here is the actual circulation. Think about it. There's spiral bands, and if you've ever been with a hurricane coming at you, it's kind of weird. You'll get a little bit of light rain from maybe the initial band, then it stops. Then you get some heavier rain showers with the next band, then it stops. Then you get some stronger rain showers, and then it stops. This is the progress with a hurricane. You get different bands of rain showers, each one progressively more intense, each one with more wind, till you finally get into the eye wall and the main area of the storm. This happens when these are purely tropical systems. Now, when they get up to the northern latitudes where we live, sometimes they do begin to transition to extratropical cyclones. When that happens, the rain field might spread out more. The winds maybe come down some. So what are some necessary conditions? Well, they need a very high sea surface temperature. It's got to be greater than 80 degrees to 150 feet depth. Think about that. How many areas in the world do you think that exist? Almost only place that exists is either in the Gulf Stream or a warm current somewhere, or down in the tropics. You also need Coriolis effect. Well, we know Coriolis effect goes to zero at the equator. So what happens? A hurricane cannot form at the equator. It needs to be away from the equator. That's why places like Venezuela, Aruba, get very, they just don't get them. Every once in a while, going to get close, but typically they stay north of that area. You can see the different warm currents here moving off the United States or over the Gulf of Mexico or the Caribbean. These can be very warm and very deep. And here's the definition that we talked about without nothing within 5 degrees. One other thing you want is weak winds aloft. So we don't want wind shear. We want these thunderstorms to be able to go up and just keep going up in the same area. We don't want them getting tilted. Now, when we talked about thunderstorms this past week, we wanted them getting tilted. Now we don't. So Atlantic hurricanes during El Nino, when winds are much stronger typically, are kind of more infrequent. So here is how many storms typically occur around the globe. These actually went up in numbers in the last couple of years when they did the new averages. But the Pacific Ocean actually receives slightly more than the Atlantic does. However, the Atlantic is where we're going to get the weather from, because think about it. These things are down in the southern part. They're on the trade winds. Trade winds move towards the west. They go east to west. So the hurricanes that form in the Atlantic are moving towards the U.S. The hurricanes that form in the Pacific are moving towards China, Southeast Asia. And here you can see the areas that are mainly part of that. Here you can see the seasons too. Look at this. Most of our hurricanes develop mid-August to mid-October. Then they really drop off. There have been some in May, and there have been some in December. Matter of fact, there's even been 1 or 2 in January now. Kind of strange, but they do occur. So the key to where they begin to form is we want the warmer waters. Well, the warmer waters initially are right here over the Gulf of Mexico, the Caribbean Sea. They gradually spread across the Atlantic here, and then more systems begin to come off of Africa during the summer, and we get more and more big hurricanes developing, have longer tracks. They form in the middle of the ocean and move. They're the ones that tend to become stronger. However, water temperatures are so warm in the Gulf of Mexico and the Caribbean, sometimes hurricanes can develop and intensify very quickly there. Many of these occurrences form on an easterly wave, just an area of low pressure. Interestingly, most of the precipitation occurs on the eastern side of the wave. So in other words, as it's approaching and moves by you, you don't get the rain, but you will get it on the other side of it. Some of these are convective cloud clusters that may develop. Another thing that influences hurricanes, it actually destroys them, is the Saharan air layer. It's a dusty, very stable layer of air. Think about it being developed over Africa. Maybe you get a thunderstorm that, because of the evaporation, no rain reaches the ground, but the wind does. It blows the dust up from the Saharan desert into that area. What happens then? That is carried across the Atlantic, and as it does that, the air is very hot, dry up aloft, and very windy actually. So all that moisture down below it is hitting that dry air, getting pushed apart by the dust that's keeping the sun from getting too much heating. You wind up killing hurricanes or tropical cyclones when Saharan air layers come in contact with them. Sometimes they move through them and they're able to redevelop after the layer goes by. So we want a lot of latent heat with these storms, which comes from the evaporation that condensing into the storm. All that cooling triggers more condensation, which releases latent heat and causes the actual center of the storm to warm with time. And there is a big divergence aloft because that is where literally an anticyclone exists. Here's your definitions: 23 mile per hour or greater for a depression, 39 mile per hour or greater, and they become named when they're tropical storms. Hurricane 74. The damages from a hurricane, the worst one is storm surge. We just had Ian. If you got to see some of the Weather Channel or some of the other viewers that were out there where they actually showed the storm surge coming in to Fort Myers Beach, you could watch it rise up literally within an hour or two and go from half a foot to 6, 7, and eventually up towards 15 feet in some of those areas. Imagine if you were there in a house. You wouldn't stand much of a chance with that kind of a storm surge. And that water is being pushed by 100 and some mile an hour winds. Flooding is another problem. High surf. Winds, yeah, they can cause some problems. So here you can see the devastation caused by flooding. Hurricane Harvey came into Houston. It caused tremendous rainfall. Ridiculous amounts. Think about it. A hurricane forms over the middle of the tropical oceans. What's it getting? It's getting tons and tons of moisture. As long as that's its source region, it starts out wet, very wet. So gradually as it moves inland, it's dumping all this rain because it had all that moisture to accompany it. There can also be tornadoes with hurricanes. What happens is you want wind shear for a tornado. Well, you got lots of convection with hurricanes and tropical cyclones, especially even in the outer bands of them. But when these winds hit the coast, we know winds drop because of friction. There's less friction over water, so you wind up with lower winds at the surface and stronger winds aloft. What happens? You wind up with potential wind shear and potential for tornadoes. This is particularly true to the right side of the storm's motion. That's where you're going to get most of them. Storm surge we've talked about, and you can actually see a demonstration of it and the damage caused by it. Camille still takes the record as the highest that we know of when it came ashore at almost 25 feet. Sandy, one of the largest hurricanes on record, size-wise, not strength-wise, had over a 12-foot storm surge that came to Kings Point. And you're going to write all about that for me. I'll be looking forward to hear what you talk about storm surge when that storm hits. And we have forecast models for that. And the Atlantic multi-decadal oscillation, what is it? The Atlantic warms up over time for some reason. We're not exactly sure what. But there are decades, and I mean decades, where the temperatures are warmer. Notice in the 1960s and 70s, I was in college during the 70s, and I kept wanting to see a hurricane. I'd never seen one. I was at Florida State. The whole time I was there, the whole 4 years, nothing came close to Florida. Why was that? Because we were in the cold phase of this multi-decadal oscillation. Now we're in the warm phase. And so is another influence on it. And here are some conclusions the World Meteorological Organization Task Force had for it. So lots of people have moved into these hurricane locations. Florida, booming. Coastal Carolinas, coastal Texas. Because back in the 70s and 80s, there wasn't much in the way of hurricanes. And even now, if you look at it, hurricanes don't cover huge areas. The areas they do cover, you see extraordinary damage. They can see where they break apart barrier islands. And we try to get people out. It's hard. Sometimes evacuations are very difficult. So let me just look at one last thing here. This is what used to be Tropical Storm and Hurricane Lisa. What's left of it is just moved across the Yucatan. You can see the circulation, outflow, aloft, anticyclone up there, divergence, and some convection here. But it's not moving much. It's pretty much in the middle here. Here's an interesting one. I hadn't noticed this one. I found it was put out by NOAA. This was from a TV station that published it. What I want you to watch is there's convection that shows up here, and you can see the eye is right here. Fort Myers Beach is right in here. Oh, up here, Tampa. Winds are blowing out. That's why the bay went out in Tampa, but they're blowing in here. So as this thing is moving in here, you can see the eye wall. Lightning too occurring. And oh yeah, some of the outer bands have lightning. These were where some tornadoes eventually developed. But you can actually see the spin with the eye wall as it's coming inland. Tremendous winds, all of that occurring. The hurricanes moving right across Fort Myers Beach, Sanibel Island, destroying it. So hope you got a little bit out of this, and let me know if you have any questions.